Welcome to Invent Oregon and this instructional video about design thinking. My name is Bill Dresselhaus and the topic for this video is Design Thinking Making. In the video on Design Thinking Explained, the 5 phases of design thinking were presented. This video will cover the 4th phase of design thinking, making. It is about the creation of physical simulations and mock-ups of the best potential ideas and concepts that result from the design thinking ideation phase. Physical design mock-ups are of essential value and application in design thinking and product design and development. In this video, the focus will be on low and high fidelity concept mock-ups. Nothing can replace the touch and feel, manual handling, and evaluation of a physical simulation mock-up. Sketches and CAD models are valuable in many ways, but creating and using physical mock-ups greatly increases the success of a product's design. To create adequate product mock-ups, one must have the proper tools, materials, and skills to do so, as well as an appropriate work environment and space for successful creation. Physical design mock-ups are made with simple tools and processes that anyone can do. To use a famous comment as applied to physical design mock-ups, they can be made by any means necessary. Physical design mock-ups are made of simple, easy-to-work, and readily available materials such as illustration board, foam core board, balsa wood and basswood, Legos and K'NEX toy parts, and other appropriate materials and parts. Joining and connecting the materials for mock-ups is also simple and uses familiar and easily available adhesives and methods such as tape, superglue, wood glue, and hot melt glue, among others. Paper mock-ups, as simple as they are, can be very valuable even throughout an entire project. They are easy to create, modify, and they facilitate fast responses. Rough, low-fidelity mock-ups can be made from all kinds of simple materials, from paper to corrugated cardboard to Lego blocks, and quickly joined with tape or superglue. These rough, low-fidelity mock-ups are usually created early in the product development process to quickly evaluate various ideas, concepts, and configurations during an initial exploratory design stage. Simple block mock-ups of a product's components can be created and then assembled into various component configurations to help determine the optimum product layout and orientation of components. It is good process to first make simple block mock-ups of all of a product's possible components, including multiples, to be able to create several alternative product configurations. These component mock-ups are then used to create various three-dimensional compositions of a product's layout possibilities and help decide on a final product configuration, component selection, and part layout. This component block configuration process also helps with optimizing a product's design for usability, assembly, cabling, airflow, service, maintenance, and upgrade. As a product design develops, more precise product component mock-ups can be made to get a more accurate product configuration, architecture, orientation, layout, and detailed design. Often, creating every single component and part of a product in its later development stages can help to find critical issues such as assembly, manufacture, service, repair, accessibility, and maintenance. These kinds of complete product precision mock-ups also help others outside of product design visualize the overall product better than can even a CAD image on a screen. Low-density and high-density foam can also be used for rough and precision mock-ups. These can be handcrafted or machined to specification. Often, actual product environments are unable to be accessed easily or as frequently as needed for product design form and fit evaluation. These real environments and their features can be mocked up and taken to be used in the design lab for simulated study. In such cases where a mock-up of an existing real product space and components is created in the design lab, the product design form, fit, service, accessibility, and other key issues can more easily be investigated and tested. Physical design mock-ups where multiples of all the relevant components are simulated lend themselves to excellent group collaboration and evaluation. All parties from various key disciplines can actively participate in the product configuration process. For large-scale projects where an accurate perception and feel for space, human movement, and interaction is essential for design success, full-size mock-ups can be created from lightweight and easily constructed materials. Quite often, for large-scale products, it is appropriate to create early scaled-down mock-ups for the systems for exploration. Such scale mock-ups can be very precise and represent the larger systems adequately for early evaluation. After these scaled-down concepts are reviewed, larger full-scale mock-ups can be made. In later stages of development, where precise product part and component detail specifications are available, precision machined and crafted product components and parts can be fabricated to represent a precise assembly. Even at this stage, design issues are often discovered when each detail is created for evaluation. Laser cutting of flat wood, plastic, or bamboo sheets can be very useful to product mock-up making process. With the advent of CAD and 3D printing, it is possible to create simple and complex CAD models of product parts and components at any stage of product development and then 3D print them for evaluation and testing. 3D printing can be a very effective process to not only make accurate physical product representations, but also evaluate the CAD models as they develop through the design phases. In the end, the product designer has multiple methods and materials available to make physical design mock-ups. What type and method is chosen will depend upon the design simulation need in the particular phase of the product development process. Thank you for watching this video. Have a great design day.